and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to solve a quadratic equation by completing the square. Let's start off with an example to help us remember the process of creating a perfect square trinomial. So in part A, it says find half of the linear coefficient and then square that value and add it to both sides of the equation. So our linear term in this problem is negative 6x. So if they want us to find half of the linear coefficient, what they're asking us to do is to find half of negative 6, and then they want us to square it. So basically what we're doing is we're dividing it by 2 and then squaring it. So negative 6 divided by 2 is negative 3, and then when we square negative 3, we get positive 9. Now, the second part of what they want us to do then is to add that number to both sides of the equation. So on the left side of our equation, we have x squared minus 6x, and they want us to add 9. And on the right side of the equation, we had a 16, and they want us to add 9. So in part A, we simply took half of the linear coefficient, squared it, and then added it to both sides. In part B, it says the left-hand side of the equation is now a perfect square. Write it as a binomial squared. So let me write down our equation again, but I'll simplify it a little bit because on the right side we have 16 plus 9, which I can combine that to get 25. Now, if I were to factor this left side, I need two binomials that I could multiply together to get x squared minus 6x plus 9. Well, to get x squared, I could use x and x. And then for the 9, I could use 3 and 3. Now, to get those to add up to negative 6, I would simply need to put a minus in front of both of them. Now, we can write x minus 3 as a binomial squared. So this would be the same thing as x minus 3 squared equals 25. Now, once we have it written in this form, we can solve this using our square root property. So in part C, they want us to solve this equation. X minus 3 quantity squared is equal to 25. So remember in previous lessons, we've learned that we can take the square root of both sides, and that the square root of x minus 3 squared would simply be x minus 3. The square root of 25 would be plus or minus 5. And then I just have to get x by itself by adding 3 to both sides. So x would equal plus or minus 5 plus 3. So x would equal 5 plus 3, which is 8. And x would equal negative 5 plus 3, which is negative 2. So what we just did in that first example is we solved the equation by creating a perfect square trinomial, and then we used the square root property to solve. So in example 2, it says solve the equations below by completing the square. So what we want to do in problem A, we have x squared plus 12x equals negative 16. We want to create a perfect square trinomial. So to do that, I'm going to put x squared plus 12x plus something is going to equal negative 16 plus something. Now, to figure out what the plus something is, remember, you're going to take your coefficient of the linear term, divide it by 2, and then square it. So 12 divided by 2 is 6, and 6 squared is positive 36. So that's the number we're going to add to both sides. So I'll put a 36 here and a 36 here. Now, when we factor this, x squared plus 12x plus 36, over here I'm going to combine negative 16 plus 36. That would give me positive 20. So to get x squared plus 12x plus 36, to get x squared, I would need an x and an x. To get 36, I would need a 6 and a 6. To make those add up to positive 12, I would need to make them both plus. So I can rewrite that as a binomial squared. Now, once you have your binomial squared, then you can solve it with your square root property. So to solve this, I'll take the square root of this side and the square root of this side. So the square root of x plus 6 squared is simply x plus 6. Now, the square root of 20, we're going to need to simplify that a little bit, so I'll do it right here. Square root of 20 would be square root 4 times square root 5. The square root of 4 is 2, and the square root of 5. So this would be plus or minus 2 square root 5. And then I'll just subtract 6 from both sides. So x would equal plus, well, you know what, I'm going to write it like this. Negative 6 plus or minus 2 square root 5. All right. Problem B, we have x squared plus 2x plus 4 is equal to negative 33. Now, the first thing I want to do here is combine like terms. I need to move this 4, subtract 4 here and subtract 4 here, so that on this side we just have variable terms, x squared plus 2x. And on this side we would get negative 37. Okay, so on the left side you only want variable terms, and on the right side you only want constant terms. So now we can create a perfect square trinomial that we can add that number to both sides. So remember, to do that, you're taking your middle term, dividing it by 2, and squaring it. So 2 divided by 2 is 1, and 1 squared is 1. So we're adding 1 to both sides. All right. Now that we have a perfect square trinomial, we can write that as a binomial squared. So the square root of x squared is x. The square root of 1 is 1. So this is x plus 1 parentheses squared. And on this side, negative 37 plus 1 would be negative 36. Now we'll solve this using our square root property. So the square root of x plus 1 squared is x plus 1. Now the square root of negative 36. Now hopefully you've already learned how to simplify complex numbers. If you haven't, you may need to go back and review that. And so the square root of negative 36 is the same thing as square root negative 1 times square root positive 36. And the square root of negative 1 is defined as I, and the square root of 36 is 6. Now, generally, we don't write it as I times 6. We generally write this plus or minus 6I. Oh, I should have put that in blue. Let me redo that. So I want to put this as plus or minus 6I. Now, just subtract 1 from both sides. So we would get x equals negative 1 plus or minus 6I. So it is possible to get complex number solutions when you're solving by completing the square, because whenever you take the square root of a negative, you're going to have to use the imaginary unit I to simplify your square roots. All right. Now, what do we do when the coefficient is not 1? So on our first two examples in A and B, the coefficient of x squared was 1. What do we do in problems like example 3, where we have, say, a coefficient of 4? Let's talk about that now. Well, the first thing you want to do in part A, if you're trying to solve this equation by completing the square, is you want to rearrange it so that only variable terms are on the left-hand side. So when I do that, that would give me 4x squared minus 24x, and that's going to equal to, I want to subtract 11 from both sides, so that would equal negative 11, okay? So we rewrote that equation so that it only had variables on the left-hand side. Now, in part B, it says factor out the numerical greatest common factor. So our numerical greatest common factor is 4. So if I divided each of those terms by 4, 4x squared divided by 4 would give me x squared. Negative 24x divided by 4 would give me negative 6x. And that's equal to negative 11. In part C, now use completing the square to solve the quadratic. Your answers will be fractional. Okay, so what we're going to do, let me write the equation down here. We have 4x squared minus 6x is equal to negative 11. So what we want to do is, first of all, divide both sides by 4. And so these 4's would cancel, leaving me x squared minus 6x. And on this side, I'd be left with negative 11 over 4. And leave these as fractions, okay? Now, the next thing we're going to do is we're going to complete the square. So x squared minus 6x plus blank equals negative 11 over 4 plus blank. All right, so when we take our coefficient, half of 6 is 3, and 3 squared is 9. So we're going to add 9 to both sides. So this would be x squared minus 6x plus 9. Now, when I have fractions, I usually just use my calculator to add these, negative 11. But you can do it by hand. Negative 11 over 4, and I'm adding 9. Just remember to keep your, when you write your answers, don't write any decimals because it'll make it more complicated. So I wanted to turn that solution into a fraction. So 25 over 4. All right. Now we want to factor the left side. So the square root of x squared is x. The square root of 9 is 3. And that's equal to 25 over 4. Now we'll take the square root of both sides. So this would be x minus 3. And over here, the square root of 25 is 5. The square root of 4 is 2. So this would be plus or minus 5 over 2. And then I'll add 3 to both sides. So x equals 3 plus or minus 5 over 2. Now at this point, I usually use my calculator to get my final answer. 3 plus 5 over 2 is 5.5, so I'll turn that into a fraction. 11 over 2. And then I'll go back up here and change that plus to a minus, and that would be 1/2. And so the instructions said that our answers would be fractional, and indeed, in this problem, both of our answers were fractional answers. All right, now let's repeat this process a couple more times so that we can get it down. What do you do when your coefficient is not 1? So in problem A, we have 2x squared plus 4x plus 52 is equal to 0. The first thing you want to do is rewrite it so that you only have variables on the left side. So 2x squared plus 4x equals, and I want to subtract 52 from both sides. So that would be negative 52. Okay. Then you want to factor out your greatest numerical coefficient. So here that would mean factoring out a 2. So 2x squared divided by 2 is x squared. And 4x divided by 2 is 2x equals negative 52. Now, once you have it in this form, we can solve it. I want to divide both sides by 2, so we can get rid of that 2. And that would leave me x squared plus 2x equals negative 26. Now I can complete the square. X squared plus 2x plus something equals negative 26 plus something. So to get the plus something, remember we're taking our middle term, dividing it by 2 and squaring it. So 2 divided by 2 is 1, and 1 squared is 1. So we're adding a 1 here and a 1 here. Now, when I rewrite that as a binomial squared, the square root of x squared is x, the square root of 1 is 1. So this would be x plus 1 squared equals negative 25. Now square root both sides, and we have x plus 1 equals, and remember, just like our example above, square root of negative 25 is the same thing as square root negative 1 times square root 25. And square root of negative 1 is defined as I. Square root of 25 is 5. So down here, this would be plus or minus 5i. Now, subtract 1 from both sides. So x would equal negative 1 plus or minus 5i. All right, pause the video and try problem B on your own. All right, welcome back. Let's see how you did. The first thing I did was put all the variables on the left side and put the coefficient or the constant term on the right side. Then I factored out a 3 to get 3 parenthesis x squared plus 8x equals negative 72. Then I divided both sides by 3. And I got x squared plus 8x equals negative 24. Then I completed the square. So half of 8 is 4, and 4 squared is 16. So I added a 16 to both sides. And then I made a square of a binomial. This would be x plus 4 parentheses squared. Over here we would get negative 8. Then I took the square root of both sides to give me x plus 4 equals, I need to come down here and simplify square root negative 8. This would be square root negative 1 times square root 4 times square root 2. So this would be I times 2 times square root 2. So plus or minus 2i square root 2. And then just get the x by itself by subtracting 4. So x equals negative 4 plus or minus 2i square root 2. And that concludes today's lesson, solving quadratic equations by completing the square.